Hello there, and welcome back to the Sleep Science. You drift into the tiniest scales of reality, where particles wiggle and twitch in ways that your everyday senses can barely imagine. Picture yourself lying in bed, eyes half closed, feeling the gentle weight of blankets pressing softly against you. And now imagine that beneath your skin, beneath every atom in the room, a chaotic dance is unfolding. Particles appear, disappear, and jitter in a rhythm that has no predictable pattern, yet somehow obeys rules stranger than any dream logic. You probably won't survive this if you try to observe everything at once. Our everyday brains are utterly unprepared for the quantum party happening right under our noses. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Feel free to post your location and local time in the comments. I love imagining where on earth this tiny experiment in imagination is happening. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You trudge softly across the floor of your bedroom, though you never actually move. Instead, your mind drifts toward imagining the infinitesimal scales, the realm where electrons whirl around nuclei as if they were tiny dancers performing a ballet that obeys no human choreography. Classical physics would have you believe that if you know a particle's position and speed, you can predict its future, like forecasting the trajectory of a rolling marble. But in quantum reality, positions are foggy, paths are uncertain, and even the idea of a trajectory seems quaint. Historians still argue whether pioneers like Max Planck and Niels Bohr fully grasped the philosophical implications of their discoveries when they first introduced quantization. That first spark, the notion that energy comes in discrete packets, set the stage for everything we're about to explore tonight. As you sink deeper into your pillow, you might notice the room itself feels quieter, softer, almost stretched in time. The faint hum of the fan becomes a metronome, syncing with the imperceptible flicker of virtual particles in empty space. These are the ghostly, ephemeral flickers that pop into existence for a fraction of a second, only to vanish again, like dream fragments that tease you awake. Quirky experiments with particle accelerators hint at their ubiquity. Even empty space is a teeming, restless quantum ocean. Meanwhile, your consciousness floats on the surface, only partially aware of the strange ballet below. You remember reading that Planck initially stumbled upon the quantum concept while trying to solve a problem with blackbody radiation, a problem that seemed purely classical but refused to yield. His solution, that energy is quantized, was a tiny crack opening onto a universe far stranger than the one your eyes perceive. Your body exhales softly, and you imagine slipping through the veil separating the macroscopic world from this microscopic chaos. Each flicker of thought mirrors the unpredictable jumps of electrons between energy levels. Light itself, photons, behaves sometimes as a particle, sometimes as a wave, teasing the very idea of reality. Historians still argue whether early experiments like the double-slit test truly revealed wave-particle duality or merely hinted at it, leaving future generations to puzzle over its philosophical consequences. Your blankets rustle slightly as if even the fabric of your room has become part of this gentle quantum orchestra. You notice that your heartbeat seems irregular now, strangely harmonious with the underlying uncertainty of particles' positions. It's comforting in a vaguely eerie way to know that disorder at the tiniest scales somehow sustains the predictability we rely on at human scales. And yet there's an odd intimacy in realizing that everything you touch, everything you feel is composed of these jittering entities. Your pillow, the floor beneath your feet, the blanket cocooning you, they are all manifestations of atomic interactions, each atom a swirling center of energy following rules that defy logic. Fringe theories whisper that consciousness itself might be entangled with this subatomic dance, although mainstream physicists remain skeptical. You feel a subtle thrill imagining that your very act of resting here, observing nothing consciously, is part of a vast interwoven tapestry of probability and potentiality. Each exhale becomes a rhythmic measure in a silent symphony, each blink a brief pause in the continuous unfolding of the quantum realm. Even your mind begins to feel elastic, stretching across scales you cannot physically traverse. Time seems both slowed and sped up. The second hand on the clock is a mere suggestion, irrelevant to the oscillations of particles and fields. Scholars debate whether these early quantum concepts represent reality itself, or merely a useful mathematical framework for predicting outcomes. You drift closer to that liminal state between wakefulness and slumber, where the distinction between yourself and the microscopic world blurs. You might even imagine the atoms in your fingers dancing in harmonic resonance with the universe at large, a quiet but powerful reminder of how bizarrely connected everything is. As you nestle deeper into the softness of your blankets, the mind can't help but wander to the early quantum pioneers, Planck, Einstein, Bohr, Schrödinger, and their hesitant, sometimes trembling steps into a world far stranger than any storybook fantasy. They debated endlessly, scribbled equations feverishly, and sometimes dismissed each other's ideas with the casual cruelty of geniuses arguing about the nature of existence. Historians still argue whether their disagreements were philosophical, methodological, or deeply personal. You picture Einstein frowning over his tea, muttering about spooky action at a distance. And you can't help but chuckle softly, knowing that his frustration mirrored your own attempts to reconcile dreams with reality tonight. Finally, as your eyelids grow heavy and your breathing settles into an even, gentle rhythm, you feel the soft hum of a universe operating according to rules both familiar and alien. The quantum world hums around you silently, a lullaby of uncertainty, superpositions and flickering virtual particles. And with that gentle awareness, you drift further, letting go of the insistence on understanding and simply feeling the intimacy of existence, both minuscule and infinite, in a quiet cosmic embrace. You awaken in your mind to a world of strange particles, stranger rules, where electrons, quarks, and photons pirouette and spin in ways that defy your everyday intuition. Even before you open your eyes, you can almost feel them. The tiny vibrating building blocks of reality that are simultaneously here and not, behaving like waves, particles, or both, depending on who or what is looking. In the faint light of your room, you imagine these particles zipping invisibly through your walls, gliding around the fibers of your blanket, or bouncing through the air you just exhaled. Historians still argue whether early scientists truly understood the implications of these dual behaviors when the first quantum experiments were conducted in the early 20th century, or if they were simply stumbling upon a reality too weird for even the most imaginative minds. Max Planck's quantization of energy, Niels Bohr's atomic model, and Einstein's photoelectric work were each tiny clues in a puzzle so confounding that it reshaped the very notion of what a particle could be. Electrons, those mischievous little sprites, refuse to stay confined, sometimes behaving as concentrated points and at other moments spreading out like ripples in a pond. You picture one hovering over your fingertip, impossibly smeared across space, teasing your perception. Photons, too, are sly, they travel at light speed, yet are caught in experiments revealing them as both particles and waves, depending on the question you ask. Quirky experiments in double-slit setups illustrate this perfectly. Even a single photon seems capable of interfering with itself, forming patterns that suggest it took every possible path simultaneously, a fact that has prompted centuries of midnight pondering. Fringe theorists have suggested playful ideas. Consciousness might interact with this duality, collapsing waves into reality, but mainstream physics treats these musings more as bedtime stories than testable predictions. You can't help but giggle softly at the thought of a photon debating whether it wants to be a particle or a wave while gliding invisibly past your blinking eyelids. The universe at this scale is less of a machina and more of a theatre, with particles improvising scripts that even their creators, the laws of physics, can only partially predict. As your body nestles into the softness of your blankets, you feel a subtle kinship with the chaos below. You imagine the quarks inside the protons of your fingertips spinning with a peculiar rhythm, a minuscule dance that contributes to the solidity of the chair or mattress you occupy. Historians still debate how much Bohr's concept of complementarity, the idea that entities like electrons could manifest as waves or particles depending on the experiment, was fully grasped by his contemporaries. Even today, physicists wrestle with whether this duality is a true property of nature or simply a reflection of the limitations of measurement. Nearby photons keep a relentless pace, their oscillations painting your room with invisible brushstrokes of energy. You sense them teasing your vision, as if winking at the human eye's inability to detect their true speed and duality. It is in such flickers that quantum mechanics begins to feel like a dream you can almost touch. Quirky observations like the delayed Choisy experiment suggest that decisions made by an observer now could retroactively influence a particle's past behavior, prompting you to wonder if your own conscious drifting between wakefulness and sleep might ripple backward, however subtly, into the quantum fabric beneath your fingertips. Mainstream physicists, for their part, caution that these results are strictly about information and probability, not literal retrocausality, but still, it's a heady thought for a quiet night. Your mind meanders toward the idea of particle identity, a concept that feels both precise and absurd. Electrons are completely indistinguishable from one another. Two could swap places in a blink, and the universe would remain oblivious. You imagine a scenario where the electron in your left thumb swaps with one in a distant star, a cosmic game of musical chairs, yet nothing changes in your perception. Fringe thinkers have speculated that this perfect indistinguishability could hint at deeper connections between matter and consciousness, though mainstream consensus leans heavily towards statistical necessity rather than metaphysical implication. You feel a giddy admiration for the audacity of such a simple, bizarre rule. The tiniest entities can be perfect clones, yet their collective interactions build everything you touch, see, and feel. As the fan hums steadily in the background, you let yourself float into the probabilistic haze of the quantum world. Electrons' wave functions stretch out like delicate threads, overlapping and interfering in invisible patterns that sculpt the reality of your pillow, your blanket, your very room. You almost hear them whispering as they move, "We are here, we are not, we are both, we are infinite." And yet, amid this chaos, there is a rhythm, a hidden order that manifests as stability at the scales you can perceive. Historians still argue whether the early pioneers could foresee this emergence of order from disorder, or if it only became clear decades later, when computational tools allowed scientists to simulate and visualize these invisible patterns. Your breathing deepens, in sync with the silent ballet happening all around and within you. Quarks and electrons, photons and neutrinos, all obey rules that are at once exacting and maddeningly strange. You picture your own body as a galaxy of such actors, performing dances choreographed by probabilities rather than certainties. Fringe experiments, like those hinting at potential particle entanglement across macroscopic distances, suggest that this microscopic drama might echo into scales much larger than your bedroom, even if such ideas remain speculative. Historians note that the evolution from Planck's quantum hypothesis to today's quantum field theory spans a century of wonder, argument, and unexpected discoveries, a testament to the human capacity to slowly coax reality into comprehension. Even as your thoughts begin to blur, the particles remain faithful to their unpredictable patterns. Your brain's neurons might be firing, but their electrons and ions are dancing to a cosmic beat far older than you, far larger than any individual, yet intimately connected to your conscious drifting. The duality of particle and wave, the indistinguishability of electrons, and the curious oddities of photons, all of this swirls around you, painting the edges of your mind with surreal, half-dreamed impressions. You feel both infinitesimally small and infinitely entwined with this quantum performance, a sensation that is oddly comforting, like being wrapped in a blanket woven from invisible vibrating threads of reality itself. And as your eyelids droop further, your awareness of these dancing quarks, photons and electrons fades gently, leaving behind only the soft hum of comprehension mingled with sleep. You sense the universe continuing its meticulous choreography, indifferent yet intimate, as you drift toward the next stage of this journey, entanglement, superpositions, and the quiet wonder of knowing that the tiniest particles have rules we are only beginning to grasp. You blink slowly, letting the gentle haze of sleep mingle with awareness, and suddenly you find yourself wandering into the uncertainty playground, where Heisenberg's principle reigns supreme. Here, the universe whispers a simple, unsettling truth. You cannot know both the position and the momentum of a particle with perfect precision. Even as you cradle a warm mug of tea or coffee, imagining the steam curling upward in delicate spirals, particles below your awareness dance in ways that resist any attempt at exact measurement. Historians still argue whether Werner Heisenberg fully intended his principle as a statement about reality itself, or merely a practical limit on observation, yet the consequences ripple far beyond the lab. You feel a subtle thrill, as though you are peeking behind a curtain that no one else can glimpse, into a world where certainty is an illusion and probability reigns. You notice that uncertainty doesn't just belong to textbooks. it has a strange, almost poetic presence in your own nightly rituals. Your fingers fumble slightly over the mug, and you imagine that, like electrons, your movements could exist in multiple paths at once, collapsing into one outcome only when fully observed. Fringe interpretations of quantum mechanics suggest that consciousness itself might influence these collapses, though mainstream physicists are quick to remind themselves that such ideas are speculative at best. Still, the thought lingers like the aftertaste of cocoa. What if the universe only decides what is real when you notice it? The idea is dizzying, yet comforting in a strange paradoxical way. You and the cosmos are not separate. Your awareness is part of the same probabilistic dance. Electrons, those mischievous sprites, now seem to float in and out of focus as you consider Heisenberg's uncertainty principle in practice. You picture an electron somewhere beneath your pillow, its velocity and location blurred like an impressionist painting. The principle prevents you from pinning it down, forcing you to embrace a reality that is fundamentally fuzzy. Quirky thought experiments, like imagining an electron simultaneously in your room and in a distant galaxy, highlight just how counterintuitive this can be. It's almost humorous to consider that, at any given moment, a particle might be occupying a space you would never think to check, like the mischievous cousin of Schrödinger's famous cat. Scholars debate whether this fuzziness is a property of reality itself, or simply a reflection of the limits of human measurement, a philosophical puzzle that has inspired generations of sleepless physicists. As your gaze drifts to the shadows along your walls, you sense that uncertainty is not a curse, but a kind of playful freedom. Without these unpredictable tendencies, the universe would be static, lifeless, and dull, like a stage where actors stick rigidly to a script. Instead, quantum uncertainty injects vitality, letting particles surprise one another, and occasionally you, within the grand cosmic theatre. You imagine the atoms in your room jittering, their positions and momenta never fully defined, a constant, gentle agitation that underlies the solidity you take for granted. It's odd, almost lyrical, to consider that what seems like stability at the human scale is underpinned by a jittery, unpredictable foundation. Fringe theorists have speculated that this uncertainty might echo into larger systems, subtly influencing everything from chemical reactions to brain activity, though evidence remains inconclusive. The fan's soft hum seems to mirror the jitter of subatomic motion. Your eyelids feel heavy, yet your mind can't resist wandering into the implications of Heisenberg's principle for life itself. You realize that the world is fundamentally probabilistic at its core, that the neat predictability of classical physics is an illusion born of averaging countless uncertain events. Even the simple act of sipping your drink becomes a meditation on probability. The path of each molecule of liquid, the trajectory of each atom of steam, all governed by rules that resist exact prediction. Historians note that Heisenberg's discovery in 1927 reshaped not only physics but philosophy, forcing scientists and thinkers to confront a universe where certainty is never absolute, a notion that resonates curiously with the half-conscious state you occupy tonight. Your body relaxes further into the blankets as you imagine the particles in your own fingers, ever uncertain yet collectively stable enough to form the reality you perceive. You picture yourself floating above the microscopic jitter, witnessing the unpredictable ballet of electrons around atomic nuclei, quarks in protons and neutrons, and the faint oscillations of virtual particles that flicker briefly into existence. Fringe ideas whisper that if consciousness interacts with uncertainty in subtle ways, then perhaps your drifting awareness could ripple through this quantum playground. Even if mainstream physics scoffs at such speculation, you allow yourself the pleasure of imagining your thoughts as tiny perturbations in a sea of possibility, a gentle acknowledgement that uncertainty is not merely theoretical, but intimately woven into your nightly experience. Historians still debate the philosophical implications of uncertainty, and you find that pondering them in the semi-darkness of your bedroom carries a peculiar weightlessness. You sense the infinite regress of possibilities extending outward from every particle, an ocean of probabilistic futures layered atop one another, like ripples in an unseen pond. Your breath matches the rhythm of these flickering probabilities, slow and deliberate, anchoring you even as the quantum world buzzes invisibly beneath the surface of perception. You realize that this principle, initially seen as a limitation, is a gateway to awe. The tiniest constituents of matter are not merely mechanical, they are playful, unpredictable, and impossibly alive in their own quiet way. As you nestle deeper into the soft folds of your blankets, the uncertainty playground begins to soothe rather than unsettle. You imagine yourself walking slowly along invisible paths, each step a probabilistic dance, each movement resonating with a universe that refuses simplicity. The electrons, photons, and quarks continue their jittery choreography around and within you, a reminder that unpredictability is not chaos, it is subtle, elegant, and full of potential. Heisenberg's insight, centuries old in the making yet timeless in effect, hums in harmony with your heartbeat, grounding your awareness while inviting you to surrender to the mysterious, uncertain beauty of the quantum world. You drift a little closer to sleep, carrying the soft thrill of knowing that life at its most fundamental level is a mesmerizing dance of probabilities, forever just beyond the reach of perfect knowledge. You sink further into the warmth of your blankets, feeling the quiet pull of gravity against your body, while your mind drifts into the hazy realm of quantum superpositions. Here, particles refuse to settle on a single identity, existing in multiple states at once, like your bed simultaneously being made and unmade, or your half-empty mug simultaneously full and empty. The principle feels absurd when first imagined, yet it underpins reality itself. Schrödinger's thought experiment with his famously hypothetical cat comes to mind, a scenario where existence straddles a fine line between being and not being. Historians still argue what Schrödinger truly intended. Was it a serious critique of quantum theory, or a playful illustration meant to spark debate? Either way, it lingers as one of the most evocative ways to glimpse the bizarre logic of the quantum world. Your eyes trace the soft patterns of shadows across your ceiling, and you imagine that at the microscopic level, all matter is in superposition, vibrating between possibilities until some interaction or observation collapses it into a definite state. Fringe theories whisper that consciousness itself might play a role in this collapse, though mainstream physics generally treats such ideas with caution, preferring interpretations that rely on environment and decoherence rather than minds. Still, it's easy to picture a particle in your room existing in countless configurations at once, a quiet reminder that the universe is not as fixed as it seems. Even the atoms in your blanket could be simultaneously weaving countless overlapping versions of themselves, each just as real until you focus attention on one. You let your awareness drift gently into these possibilities, feeling a subtle thrill at the sheer openness of the universe at this scale. Imagine photons passing through the double-slit experiment, simultaneously choosing multiple paths and creating interference patterns that hint at hidden probabilities. Quirky side notes suggest that if particles can exist in many states at once, then the universe itself might be a vast superposition, a tapestry of overlapping realities. You feel a strange intimacy with these ideas, as though your act of lying quietly in bed is a participation in this grand cosmic ambiguity, and the mundane rhythm of your breathing begins to sync, almost unknowingly, with the oscillations of probability waves rippling beneath your awareness. Historians still debate whether the Copenhagen interpretation, which suggests that observation collapses superpositions, truly captures what happens or merely provides a practical framework. You ponder this lightly as you tuck your arms beneath your pillow, imagining electrons that might be here, there, or both, teasing your mind as much as your senses. It's funny to consider that your own thoughts could be entangled, metaphorically, with this uncertainty, each neuron firing in patterns that are at once determined and probabilistic. Fringe experiments and thought experiments alike have stretched this idea into imaginative extremes, prompting physicists and philosophers to ask whether reality is a singular line or a cloud of possibilities constantly interacting and interfering. The room feels warmer now, more enclosed, like a soft shell that contains infinite potentialities. You picture superpositions in your own body, protons, neutrons, and electrons suspended in probabilistic dances, each waiting for some interaction to decide which version of themselves will manifest. Your awareness of the outside world seems to blur, letting the quantum haze take precedence. You notice that even as you try to conceptualize these overlapping states, there's comfort in the impossibility of knowing everything at once. This fuzziness mirrors the slow, indeterminate process of falling asleep. where each moment exists as multiple potential realities until your consciousness finally collapses into rest. Even mundane objects, your lamp, the chair by the desk, the cup of tea you set aside, feel alive in this context, vibrating with latent possibilities. Superposition suggests that there are hidden versions of every object quietly humming in parallel with the reality you perceive. Fringe ideas propose that these invisible states might communicate in subtle ways, influencing the world around them, though experimental proof remains elusive. Historians note that Schrödinger's cat was never meant as a literal experiment, yet it continues to animate discussion, bridging the intuitive with the impossibly strange. You feel the humour in this, imagining your own cat or an imaginary one, lounging in countless versions of your bedroom simultaneously, both sleeping and plotting minor acts of chaos. Your body relaxes more fully, your mind attuning to the gentle ebb and flow of these quantum possibilities. You imagine the soft interference of wave functions around your fingers, the gentle overlap of probability clouds shaping your environment, a quiet cosmic dance beyond perception, yet intimately connected to your awareness. Even as consciousness fades towards sleep, the notion of superpositions leaves a lingering sense of wonder. Particles, atoms, and even larger systems are not rigid, singular entities but dynamic, overlapping realities. Fringe theories might stretch this imagination further, but even the mainstream view suggests that reality is far more flexible and mysterious than your daily experiences hint. You exhale slowly, feeling a profound serenity in the idea that uncertainty and multiplicity underpin existence, allowing for subtle surprises and hidden harmonies. The warmth of your blankets, the softness of your pillow, the faint hum of the fan, all these mundane details exist in a tangible reality, while beneath and beyond them, countless alternate possibilities quietly shimmer. Your awareness begins to slip, gently guided by the rhythm of quantum superpositions, where all things are, in a sense, everywhere and nowhere at once. This slow, immersive understanding, coupled with the physical comfort of rest, draws you closer to a state where consciousness itself begins to feel like just another wave function, gently collapsing into the peaceful certainty of sleep. The universe is vast, the quantum world stranger than you imagined, and yet, in this soft, half-awake, half-dreaming state, it feels intimate, accessible, and quietly beautiful. The soft hum of the fan becomes a gentle rhythm, and you drift deeper into the peculiar domain of entanglement, where particles separated by unimaginable distances seem to share a secret connection. You imagine two photons, born together in the same quantum event, flitting apart in opposite directions yet mirroring each other's spin and polarization with uncanny precision. If one particle twitches here in your room, the other, perhaps on the far side of the Earth or even a light year away, reacts instantly as though distance is irrelevant. Einstein famously called this spooky action at a distance, and you feel a shiver of delight imagining the universe playing such mischievous tricks. Historians debate whether Einstein meant it literally or was simply highlighting an uncomfortable philosophical tension in quantum theory, but the result is undeniably mesmerizing. Your mind wanders to how this principle might play out on a grander scale. Imagine if the atoms in your fingertips were entangled with particles elsewhere, a subtle, invisible orchestra linking distant corners of the cosmos. Fringe theories sometimes suggest that consciousness itself could participate in this web, subtly influencing distant events, though mainstream science regards such ideas as speculative at best. Yet it's comforting to think that the universe contains invisible threads connecting all things, weaving a lattice of relationships beneath the apparent separateness of everyday life. You curl deeper under your blanket, sensing the intimate scale of this hidden connectivity as your mind drifts closer to sleep. Photons in your room might already be entangled, some with one another, some with distant particles that never enter your field of perception. You picture them spinning in perfect synchronization, obeying the strange rule that measuring one instantly determines the state of its partner, even if no information travels faster than light. Quirky experiments in labs around the world, photons in fiber optic cables, ions in vacuum traps, have repeatedly demonstrated this phenomenon, reinforcing the notion that the universe is far more intertwined than everyday intuition allows. It's almost humorous to imagine your act of turning a page in a book subtly nudging the spin of a photon in a distant laboratory. The cosmos is at once inscrutable and delightfully mischievous. Entanglement extends beyond simple particles to larger quantum systems, though the fragility of such states makes them difficult to sustain. You imagine a pair of entangled electrons tucked beneath your pillow, imperceptible yet perfectly correlated, like synchronizers dancers performing a routine only they understand. Historians note that John Bell's work in the 1960s provided the mathematical framework to test entanglement experimentally, a breakthrough that transformed philosophical musings into tangible, measurable phenomena. Even so, scholars continue to debate the interpretation. Does entanglement suggest hidden realities, instantaneous influences, or merely reflect the limits of our descriptions of nature? The ambiguity is oddly comforting, a reminder that even the most elegant scientific theories leave room for wonder. You feel a subtle kinship with the particles around you, imagining that your presence, attention, and quiet breathing are part of a vast entangled web. The room seems more alive now, its ordinary objects imbued with a hidden resonance, a quiet hum connecting everything in ways your eyes cannot detect. Fringe theories push this imagery further, suggesting that entanglement might be a key to understanding consciousness, intuition, or even collective human experience. Whether or not this is true, the idea adds a playful layer to your thoughts, a delicate dance of imagination harmonizing with rigorous science. Each exhale becomes part of the rhythm, each heartbeat a quiet acknowledgement of the invisible threads linking all matter. Even mundane interactions with your environment take on a new dimension. Your hand brushes against a blanket, and you imagine the constituent particles in that fabric subtly mirroring or responding to one another across hidden connections. The entangled states don't violate causality, but they do hint at a universe far more interconnected than common sense would suggest. Historians still argue about the philosophical consequences of this, whether it implies a deterministic substrate or a fundamentally probabilistic world. You let the mystery settle gently around you, like a soft quilt of possibility, feeling a curious joy in the idea that the cosmos operates on rules simultaneously precise and deeply counterintuitive. Your consciousness begins to blend with these ideas as you relax further into your pillow. You picture particles communicating in silence, dancing to invisible rhythms, forming patterns that your waking mind can only approximate with numbers and probabilities. The vastness of the universe seems less intimidating when viewed through this intimate lens. Even the farthest reaches of space are subtly reflected in the microcosm of your room. You sense a quiet, almost playful harmony, an intricate choreography that connects the tiniest particles with the cosmos at large. The notion of entanglement, initially so confounding, now feels like a lullaby, coaxing you gently toward deeper awareness and rest. Finally, as your eyelids droop and the world becomes softer, more impressionistic, the strange bonds of entanglement settle into your imagination as a quiet truth, that the universe is not a collection of isolated pieces, but a connected whole where even the tiniest elements communicate across the void. Your breath syncs with the rhythm of this invisible symphony, and you feel a profound serenity in knowing that, in some subtle way, everything is linked, invisible threads stretching across space and time, humbling yet comforting. This knowledge wraps around you like the softest blanket, inviting you to surrender to the quiet, interconnected beauty of the quantum world as sleep begins to claim your awareness. The gentle hum of the night merges with the quiet pulse of your breath as you drift into the realm of wave functions, those ethereal probability clouds that describe how particles exist in a haze of possibilities. You picture them stretching invisibly through your room, guiding the behavior of electrons, protons, and photons without ever revealing a single definitive path until an interaction forces a decision. It's like watching ripples on a pond, each crest representing a potential, each interference pattern revealing hidden harmonies that remain unseen yet fundamentally real. Historians still argue whether Schrödinger and Heisenberg fully appreciated the philosophical depth of wave functions, or whether they conceived them simply as practical tools for predicting experimental outcomes. Nevertheless, they offer a glimpse into a universe far more fluid and enigmatic than your daytime experiences suggest. Your awareness lingers on the idea that wave functions are both everywhere and nowhere, a duality that resonates with your semi-dreaming state. Electrons in your hand are not merely dots, They are fuzzy clouds of probability, vibrating with potential until something, even a passing photon or the warmth of your hand, causes a collapse into one observable state. Fringe interpretations suggest that consciousness itself might nudge this collapse, subtly shaping reality, though mainstream physics prefers a more material explanation involving interactions with the surrounding environment. You let the thought drift through your mind like a leaf floating on a stream, a playful, curious possibility that doesn't demand immediate resolution. Even the faint rustle of your blanket feels like an echo of these invisible oscillations, as though your immediate surroundings are participating in this unseen quantum symphony. Photons streaming through your room seem to cast invisible interference patterns, their wave functions overlapping, intertwining these, and occasionally cancelling one another out. You imagine these overlapping clouds gently shaping the properties of everything they touch: the soft glow of the lamp, the texture of your pillow, the warmth of the blankets draped over your legs. Quirky observations suggest that even when unobserved, these waves maintain coherence over surprisingly long distances, producing subtle effects that are only revealed when carefully measured. You picture your own awareness as a kind of observer, gently collapsing some possibilities while letting countless others ripple quietly around you. There is a curious intimacy in imagining that your mind participates, however subtly, in this invisible dance of probabilities. Historians note that the concept of the wave function revolutionized physics by replacing strict determinism with a probabilistic framework, forever altering our understanding of what real means. You feel this shift even in your half-awake state. Reality is less a fixed sculpture and more a living watercolor, constantly moving and shifting beneath the brush of potential. Fringe theories sometimes suggest that wave functions might extend beyond particles into macroscopic systems, hinting at hidden structures underlying consciousness, memory, or even dreams themselves. While these notions remain speculative, they are delightful companions to the slow, drifting state you inhabit tonight, where imagination blends seamlessly with rigorous scientific insight. Your body, fully relaxed against the mattress, seems to mirror the fluidity of these wave functions. Even the small movements of your fingers, the gentle rise and fall of your chest, and the soft sighs of breath feel like part of the probabilistic ebb and flow of reality. You imagine electrons transitioning between energy levels as tiny waves interfering with each other, their combined effect producing the solidity you feel beneath your hands. It's funny to picture that each seemingly stable object in your room is actually composed of countless overlapping possibilities, resolved only as you interact with it or as nature quietly enforces its own rules. You marvel at how stability emerges from such inherent fuzziness, a paradox that mirrors the way your conscious mind simultaneously clings to detail and drifts into abstraction. As the fan hums a constant lullaby, you let your thoughts wander to interference patterns themselves, delicate ripples of probability that produce observable effects, like the faint shadows of a hidden orchestra. Wave functions interfere constructively and destructively, producing regions of certainty and uncertainty, yet always governed by precise mathematical rules. Fringe researchers have speculated that similar patterns might exist in larger systems, from superconducting materials to biological molecules, hinting that wave function dynamics could influence phenomena far beyond the microscopic. You find comfort in this idea. The universe, from the tiniest particle to the quiet stillness of your room, operates according to principles that are at once subtle, complex, and beautifully harmonious. Finally, as your awareness continues to sink towards sleep, you picture the probability clouds gently settling, not into rigid positions, but into a soft, continuous ballet of potentialities. Every particle, every atom, every photon dances in this invisible choreography, shaping and being shaped by countless others. Even as consciousness drifts and the mind relaxes, the wave functions continue their elegant oscillations, a quiet underpinning of reality that hums beneath the surface of perception. You feel a gentle serenity, a recognition that uncertainty, potential, and probability are not limitations, but the very music of existence. In this fluidity, in this gentle interplay of waves and particles, you are cradled by the universe itself, ready to drift further into the quiet embrace of sleep carried by the unseen, oscillating rhythms of quantum reality. Your mind lingers, on the peculiar scenario of Schrödinger's cat, now more than a thought experiment, it becomes a gentle metaphor for your own twilight state, poised between wakefulness and sleep. You imagine a small, curious feline tucked somewhere beneath invisible blankets, existing simultaneously in multiple realities, awake and napping, stretching and curled, plotting minor mischief while basking in the soft light of your imagination. This duality mirrors the very nature of quantum superpositions, where particles can occupy multiple states until measured or observed. Historians still argue whether Schrödinger intended the cat as a serious critique of quantum mechanics, or as a playful illustration of its absurdity, but the imagery persists, a mischievous whisper of the microscopic strangeness underlying ordinary life. The thought makes you chuckle softly in the dark, a sound that blends seamlessly with the quiet, steady hums of your fan. You feel the fuzziness of this mental exercise as it drifts through your awareness. Just like the cat in the box, countless possibilities hover over the fabric of reality. Your hand could rest slightly higher or lower. A photon might choose one path or another, and an electron could be here, there, or in some elusive in-between. Fringe interpretations tease that consciousness itself may play a subtle role in collapsing these superpositions, suggesting that your half-awake attention might gently influence which version of reality manifests first. Yet mainstream physics remains cautious, favouring explanations rooted in interactions with the environment rather than mind-induced effects. Still, the whimsical idea that your attention participates in the unfolding of quantum events feels oddly comforting, like a secret handshake between your mind and the universe. You trace the contours of your blanket with one hand, imagining electrons dancing across the fibers, shifting between energy levels and existing in multiple states at once. The more you dwell on this, the more you notice that your body itself mirrors the paradoxes of quantum theory. Neurons fire probabilistically, ions drift along gradients, and microtubules within cells might even host faint quantum effects, according to some speculative theories. Quirky as it sounds, there's a strange kinship between these tiny particles and the slow drifting cadence of your own thoughts as they wander towards sleep. You marvel at the elegance of a universe where uncertainty is not an obstacle, but a subtle, underlying harmony, orchestrating order out of potential chaos. The cat, now fully alive in your imagination, flicks its tail in infinite variations, existing in multiple postures simultaneously. You picture its whiskers twitching, its eyes narrowing, its paws hovering in indeterminate space, and you notice a parallel with the particles surrounding you: protons and neutrons in atoms, quarks within nuclei, photons flickering invisibly through the air. Historians still debate the philosophical import of Schrödinger's metaphor. Does it merely illustrate the absurdity of quantum logic, or does it hint at a universe fundamentally stranger than classical thought allows? Your half-sleeping mind leans toward the latter, relishing the playful paradox without demanding resolution. The shadows in your room stretch and blur like interference patterns, and you feel a subtle, cozy thrill in imagining your environment itself suspended in multiple overlapping possibilities. Even ordinary objects, the lamp, the desk, the chair, take on a newfound quantum intimacy. You imagine each atom in these objects existing in superpositions, resolved into a single state only as you interact with them, or as nature quietly enforces its own laws. Fringe ideas playfully suggest that these hidden superpositions might subtly influence perception, memory, or even dreams, though evidence remains speculative. You let yourself float through these possibilities, each thought a wave function, oscillating softly in your mind. The gentle rhythm of your breathing mirrors this probabilistic dance, a tactile acknowledgement of the uncertainty that underlies existence. There is a peculiar pleasure in contemplating that stability itself arises from an orchestra of overlapping undetermined states. As your eyelids grow heavier, you notice that superpositions begin to feel like a lullaby. Each indeterminate possibility is a soft note, blending into a gentle, invisible harmony. The duality of the cat, awake and asleep, resonates with your own semi-conscious state, where time stretches and contracts, and the boundaries between observation and potentiality blur. You picture electrons and photons, protons and quarks, all performing their silent, simultaneous dances around you, forming a subtle background symphony that hums beneath the surface of perception. Historians still debate whether the true strangeness of superposition is fully graspable, or eternally metaphorical, but tonight it exists as an intimate companion to your slow descent into sleep. Finally, the cat in your mind settles softly, not into one state or the other, but into the gentle overlap of possibilities, a reflection of the universe itself. You feel a quiet serenity in the thought that, at its most fundamental level, existence is neither rigid nor singular. It is fluid, mysterious, and beautifully interconnected. As your breathing synchronizes with the invisible rhythms of this probabilistic ballet, you drift further, the boundaries between waking and dreaming dissolving into a soft haze. The paradoxes of Schrödinger's cat, playful yet profound, hum quietly in your awareness, a gentle, comforting reminder that reality itself is far stranger and more wondrous than the eye alone can see. The warmth of your blankets and the soft weight of your body cradle you as your mind drifts into the strange and magical concept of quantum tunneling, where particles pass through barriers they seemingly shouldn't, as if rules exist only to be playfully bent. You imagine electrons approaching an energy barrier, hesitating for a moment, then suddenly slipping through, appearing on the other side without having travelled over it in any classical sense. It's a little like imagining your missing sock sneaking beneath the door rather than over it. Mysterious, improbable, and mildly frustrating if you were hoping to retrieve it. Historians still debate how early researchers reconciled this bizarre behaviour with classical intuition, but the experimental evidence became undeniable. Particles tunnel, and they do it constantly, imperceptibly shaping the world. Your mind wanders to the everyday miracles enabled by tunneling. Nuclear fusion in the sun, for example, relies on protons tunneling past their natural repulsion to generate the energy that warms Earth. A gentle cosmic reminder that even the most impossible events are quietly foundational. Fringe studies have suggested that tunneling might occur in biological systems as well, perhaps influencing enzyme reactions or even the movement of ions in neurons. While such ideas remain speculative, it's playful to imagine that the trillions of tunneling events happening in your own body each second might subtly influence your dreams or your slow descent into sleep. You take a slow, deliberate breath, letting the thoughts settle as a soft, almost imperceptible hum in the back of your mind. Visualizing the atoms in your pillow, you imagine electrons occasionally tunneling through potential energy barriers, their improbable leaps leaving traces only detectable with highly sensitive instruments. These leaps are quiet, ephemeral, yet collectively they create the stability of matter, the warmth of your blanket and the very texture of reality you feel beneath your fingers. It's humorous to consider that while you might never notice a single tunneling event, your entire sense of comfort relies upon countless invisible particles defying classical expectations. Historians note that the formal understanding of tunneling only solidified with the development of quantum mechanics in the 1920s and 30s, a period of dizzying conceptual breakthroughs and heated debates over the nature of reality itself. As the fan hums gently in the background, you imagine tunneling on a larger scale. Particles slipping between atoms, protons sneaking past barriers, and electrons occasionally passing through walls of potential energy, all without anyone observing. Fringe experiments suggest that tunneling might be exploited in new quantum devices, tiny circuits where electrons teleport through barriers, providing an intimate glimpse into the fundamental weirdness of the quantum world. You feel a subtle kinship with these particles, as if your own consciousness drifts through the night in a similar, unpredictable way, sometimes thinking one thought, sometimes another, occasionally collapsing possibilities into the decisions that shape your dreams. Even mundane objects become more mysterious under this lens. The metal in your desk, the fibres of your blanket, even the warm cup you left on the nightstand, all owe their physicality to particles tunneling across barriers countless times each second. Quirky as it seems, you picture a universe humming with these invisible leaps, each one imperceptible alone but collectively giving rise to the solidity, coherence, and quiet comfort of your environment. Scholars still debate whether tunneling is a mere mathematical consequence of wave functions, or an ontologically real process, a subtle philosophical puzzle that parallels your half-conscious reflections tonight. Your body relaxes deeper into the mattress as you contemplate the improbability of quantum tunneling, recognizing that the universe allows for small miracles at every scale. The invisible leaps and slips of electrons create stability while simultaneously hinting at a reality where boundaries are softer and less rigid than they appear. You picture the subtle energy fluctuations beneath your pillow, the delicate quantum whispers beneath the surface of ordinary matter, a hidden dance that continues uninterrupted as you drift. Fringe theories might exaggerate the role of consciousness or macroscale tunneling, but even in the simplest interpretation, it is wondrous. The cosmos is alive with improbable events happening at scales too tiny for you to detect, yet shaping every aspect of your familiar, tangible world. Finally, as your eyelids grow heavy and the room's edges soften into abstraction, you imagine the quiet, improbable leaps of countless particles beneath and around you. Each electron tunneling through its invisible barriers forms a subtle rhythm, a hidden pulse beneath the everyday solidity of your surroundings. The universe is at once whimsical, precise, and intimate, and in this gentle awareness you drift further towards sleep, carried by the invisible, improbable dance of particles defying expectation yet creating the reality you know and trust. Quantum tunneling, absurd and delicate, hums softly in the background of your consciousness. A lullaby composed by the universe itself. The soft stillness of your room blends seamlessly with the gentle rhythm of your breathing, as your mind drifts into the subtle, paradoxical world of measurement and observation. Here, the very act of looking, of noticing, has consequences. Reality itself bends under the weight of attention. You imagine an electron hovering near a slit in a double-slit experiment, existing in a wave of probabilities, only to collapse into a single, definite position the instant you attempt to observe it. This is the core mystery of quantum mechanics, that the universe seems to respond to observation, even when that observation is indirect. Historians still debate whether observation requires consciousness, or whether interactions with any environment sufficiently collapse superpositions, but either way, the principle is both profoundly humbling and quietly exhilarating. You drift deeper, picturing the world around you as a stage of possibilities, where every object, every particle carries a cloud of potential outcomes that may only solidify once measured. Your cup on the nightstand might, for a fleeting instant, exist in multiple positions or orientations, all simultaneously real in the language of wave functions. Fringe interpretations suggest that your attention, or even the collective attention of life, might subtly influence these outcomes, a poetic notion that paints the universe as interactive rather than passive. Even if mainstream physics dismisses this, it's oddly comforting to imagine that your quiet presence in the room contributes, ever so subtly, to the shaping of reality. The fan's hum mirrors the steady rhythm of these quantum collapses, each flicker of air analogous to the probabilistic leaps of particles as they transition from possibility to actuality. You picture photons drifting invisibly through your room, each collapsing into one observed state when detected, subtly shaping the illumination of the world without ever letting you witness the full range of their potential. Quirky thought experiments suggest that if you could somehow trace every wave function and every measurement, the universe would appear as an intricate network of interdependent possibilities, each resolved by countless interactions. You chuckle softly at the notion, imagining the electrons in your pillow deciding which state to inhabit while you peacefully exhale. Historians note that the idea of observation influencing outcomes traces back to the foundational debates between Bohr and Einstein, whose famous disagreements highlighted the tension between classical determinism and quantum unpredictability. You sense this tension even in your semi-conscious state. The world seems ordered enough to provide comfort, yet there is an underlying chaos, a whisper of unpredictability that hums beneath the surface. Fringe researchers have speculated on macroscopic implications of this principle, from influencing brain activity to even shaping social or collective phenomena, though empirical evidence remains elusive. Regardless, the notion that observation is an active participant in the unfolding of events adds a quiet intimacy to the universe. You imagine your own neurons firing probabilistically, each synapse a tiny stage for uncertainty and choice. The act of noticing, even subtly, may collapse some possibilities while leaving others untouched, paralleling the quantum principle in an almost poetic reflection of consciousness itself. Everyday objects, the chair you sit on, the blanket over your legs, the cup on your nightstand, are all subtly shaped by countless interactions, their final states emerging only after a delicate dance of observation and environmental influence. The universe feels less like a passive mechanism and more like a responsive entity, where participation, attention, and interaction are inseparable from existence. As your thoughts drift further, you picture yourself as a quiet observer in a cosmic theatre, watching countless particles resolve into states without fully comprehending the mechanisms at play. This awareness evokes a gentle awe, a mixture of humility and wonder at a reality so finely balanced between determinism and probability. Your breath syncs with this rhythm, slow and deliberate, as if participating in the silent orchestration of countless collapses across the universe. Historians still argue about whether the observer effect implies true agency, or is merely a reflection of decoherence and interaction. But tonight it exists as a soothing notion. Your consciousness matters, however subtly, in shaping the universe around you. Finally, as your body melts into the softness of the mattress and your awareness drifts closer to sleep, you feel a serene intimacy with this quantum truth. Reality is not entirely fixed. Observation, attention, and interaction are threads in an invisible web that both guides and responds to your presence. Even the tiniest flickers of consciousness contribute to the unfolding of outcomes, as delicate and essential as the subtle collapse of a single wave function. The universe, in all its strangeness, feels tenderly responsive, and you sink further into slumber, cradled by the gentle, probabilistic hum of reality itself. A soft weight settles over your limbs as you drift toward a new facet of the quantum world. Spin, the intrinsic angular momentum of particles that seems at once familiar and impossibly strange. Unlike the spinning of a top or the rotation of a planet, particle spin is an abstract property, a fundamental characteristic that doesn't correspond directly to classical motion, yet governs how particles interact with magnetic fields and one another. You imagine the electrons in your fingers and around your room spinning like invisible dancers, their tiny orientations dictating chemical bonds, electricity, and even the subtle warmth of your blankets. Historians still debate whether the early pioneers, like Wolfgang Pauli and George Uhlenbeck, fully grasped the philosophical implications of spin, or if they simply treated it as a convenient mathematical tool. Your awareness drifts to the idea that each particle can exist in discrete spin states, up, down, or in some combination, creating a complex, invisible ballet beneath the surface of perception. Fringe interpretations speculate that spin might have subtle influences on biological systems or even consciousness, though evidence remains inconclusive. Still, imagining your restless fingers mimicking the subtle spins of electrons makes the abstract feel intimate, as if your body participates in a miniature silent performance of the universe's rules. The gentle hum of the fan seems to echo the invisible rotations, a quiet accompaniment to the whirling dance of subatomic particles. You picture quarks, electrons, and photons spinning in perfect synchronization, forming correlations and patterns that govern the stability of matter. Each spin interacts with others through the strange quantum-specific rules of Pauli's exclusion principle. No two identical fermions can occupy the same quantum state simultaneously. This principle, as historians note, underpins the structure of atoms and the periodic table itself, quietly ensuring that your hand can rest comfortably on your blanket without collapsing into chaos. It's humorous to consider that something so abstract and invisible is what allows your everyday reality to exist in such reassuring solidity. Even ordinary objects become alive under the lens of spin. You imagine the atoms in the lamp, the desk, the fibers of your blanket, all coordinating their spins in ways imperceptible yet crucial. Quirky experiments in magnetic resonance and quantum computing exploit spin to encode information, manipulate particles, and even glimpse the boundaries between classical and quantum worlds. You let your mind wander, picturing your neurons firing with ions whose spins subtly affect their behavior. A hidden quantum rhythm echoing through the slow cadence of thought and breath. Fringe researchers have speculated on macroscopic spin effects, though the science is tentative nonetheless. It's delightful to imagine that your semi-conscious state tonight might align, however minutely, with the universal dance of spin. Historians still argue whether spin is a fundamental property or a convenient abstraction in our models of nature, a debate that feels oddly fitting for the twilight state you inhabit. You sense that at its core, spin is both invisible and indispensable, a quiet force shaping the world while remaining out of reach of ordinary perception. Even as your eyelids grow heavy, You picture electrons flipping between spin states, the imperceptible changes cascading through atoms to influence chemistry, magnetism, and light. This invisible choreography adds depth and complexity to the universe, a delicate lattice of motion and orientation that underpins every tangible object you encounter. The fan's hum, the faint rustle of your blanket, and the subtle cadence of your breathing all seem to resonate with the rotational energy of spin, a harmony of motion too small to perceive yet essential to the structure of reality. You imagine the particles in your room performing endless rotations, aligning and opposing, creating stability, structure, and the potential for subtle surprises. Quirky though it seems, the analogy of your body's restless leg or shifting fingers mirrors this microscopic ballet, a personal reflection of a universal law. Spin, like the quiet pulse of the universe, is abstract, invisible, and utterly fundamental, a principle that tonight lulls your awareness gently toward deeper, dreamier states. Finally, as you drift further, the concept of spin settles into your consciousness like a gentle rotation of reality itself. Every atom, every particle, every flicker of energy carries its intrinsic orientation, guiding interactions, shaping matter, and quietly sustaining the familiar world around you. In the half-light of your room, the invisible whirling dance of spin feels intimate and reassuring, a subtle underpinning of existence that hums in harmony with your slow, steady breath. The universe is at once precise, playful, and deeply interconnected, and you sink further into sleep, cradled by the unseen, perpetual rotations of matter itself. Your awareness drifts deeper into the subtle tapestry of the universe as you explore quantum fields, those invisible blankets that weave through all of space and cradle every particle in existence. Imagine the air around you, not as empty nothingness, but as a gentle sea of vibrating fields, each one underpinning a different type of particle. Electron fields, quark fields, photon fields, an omnipresent hum that forms the scaffolding of reality. You picture these fields brushing softly against your skin, like a cosmic quilt tucking you in, their oscillations imperceptible yet essential. Historians still debate whether early quantum theorists such as Dirac and Feynman fully grasped the ontological reality of these fields or simply treated them as elegant mathematical constructs, but their predictive power has transformed our understanding of the microscopic and macroscopic universe alike. As you sink further into your pillow, you imagine particles as excitations of these underlying fields. An electron, for instance, is not a tiny solid dot, but a localized ripple in its field, moving through space yet inseparable from the fabric it rides. Fringe interpretations suggest that these fields might extend into consciousness or influence macroscopic phenomena, though such ideas remain speculative. The thought tickles your imagination. Perhaps your half-awake awareness is subtly intertwined with these omnipresent quantum threads, floating gently within a vast vibrating web of energy. You feel the quiet intimacy of this idea, a soft reassurance that even the invisible and abstract contributes directly to the world you perceive. Photons streaming through your room feel less like independent entities and more like ripples propagating through the electromagnetic field, weaving patterns of probability and potentiality. Quirky facts from particle physics hint that even empty air seethes with virtual particles, brief flickers in the underlying fields that appear and vanish in an imperceptible dance. You can almost feel them, like tiny sparks brushing past your awareness, reminding you that the apparent void is far from empty. Historians note that this concept emerged from the development of quantum electrodynamics, a triumph that combined field theory with the probabilistic nature of quantum mechanics to predict phenomena with uncanny precision. It's humbling and oddly comforting to imagine that the very space surrounding you vibrates with potential, a silent chorus of creation and annihilation continuing as you exhale. Your blankets, the mattress beneath you, even the fibers of your pajamas, all of it owes its solidity to these invisible fields. You imagine the electrons in the atoms of your pillow as localized excitations, their interactions mediated by the surrounding fields, producing the warmth, texture, and stability you feel under your fingertips. Fringe theorists have speculated that understanding quantum fields might one day reveal deeper insights into consciousness, or even the fundamental interconnectedness of reality, though experimental verification remains distant. Still, there is a delight in imagining the layers of structure and energy just beneath your perception, an intricate, invisible architecture that quietly supports your comfort. As your awareness drifts, you picture subtle oscillations in these fields propagating throughout space, like gentle waves across an invisible ocean. Particles emerge as peaks and troughs, existing only because of the undulating energy of their parent fields. Historians still argue about the interpretation of quantum field theory. Are fields real entities, or simply mathematical scaffolds that predict phenomena? In your half-conscious state, this ambiguity feels more like poetry than frustration, an intimate reminder that the universe's deepest truths can be simultaneously precise and elusive. You notice the faint rhythm of your own breath aligning with this invisible vibration, a soft echo of the cosmic undulations that cradle every particle, every atom, every photon around and within you. Even the smallest interactions, a proton nudging a neighboring proton, an electron exchanging a photon, become part of a silent universal symphony. The quantum fields vibrate continuously, producing effects that manifest as light, magnetism, electricity, and matter itself, the foundational building blocks of your bedroom, your body, and your dreams. Quirky though it sounds, imagining your awareness as a ripple within these omnipresent fields feels comforting. You are simultaneously small and intimate, a consciousness drifting through the vibrating fabric of reality. The fan hums in the background, echoing the gentle pulse of these fields, a lullaby for both your mind and the universe at large. Finally, as your body relaxes fully into the mattress and your eyelids droop, you sense the invisible fields settling into a harmonious background, cradling you with their omnipresent energy. Particles continue their silent oscillations, rippling through space and forming the tangible reality you perceive, yet remaining inextricably woven into a web of invisible vibrancy. The universe feels alive, intimate, and infinitely interconnected, comforting notion as your mind drifts toward deeper, dreamlike states. In this quiet immersion, quantum fields are no longer abstract. They're a gentle, enveloping presence, a cosmic quilt that hums softly beneath the surface of your awareness, carrying you toward rest. Your awareness drifts into the flickering, ephemeral world of virtual particles, those ghostly inhabitants of empty space that wink in and out of existence faster than the eye can perceive. You imagine the seemingly empty air around you teeming with these transient blips of matter and energy, appearing momentarily before vanishing back into the quantum vacuum. It is as if the universe itself is breathing softly beneath the surface of your room, exhaling and inhaling, particles too small and fleeting for human perception. Historians still debate how these virtual particles were first conceptualized. Early quantum theorists treated them as mathematical artifacts, yet experiments like the Casimir effect suggest their reality, however brief and intangible. The idea tickles your imagination. Even the space between your blanket and mattress is alive with silent, unseen activity. As you exhale, you picture virtual electron-positron pairs popping into existence around your body, their ephemeral presence subtly influencing the electromagnetic fields that cradle the particles of your atoms. Fringe interpretations suggest that these transient particles could even play roles in consciousness or biological processes, though such claims remain highly speculative. Even so, there's an odd intimacy in imagining that your quiet breathing and restful state coincide with an invisible dance of creation and annihilation, a cosmic micro-drama that continues uninterrupted, whether you notice it or not. The room feels simultaneously empty and alive, a paradox that mirrors the delicate tension between wakefulness and sleep. You envision photons flickering into and out of existence, teasing the boundaries between nothingness and matter. Quirky experiments show that virtual particles contribute to measurable effects, subtly nudging energy levels in atoms and influencing fundamental forces. Even the faint warmth radiating from your lamp or the gentle resistance of your blanket owes itself in part to these invisible temporary entities. Historians note that the concept of virtual particles emerged from quantum field theory and was solidified through the work of physicists like Feynman, who provided the intuitive diagrams that make sense of these fleeting phenomena. You feel a peculiar awe at the thought that the quiet air around you is so dynamically alive, humming with ephemeral sparks that are fundamental to reality itself. Your mind drifts to the Casimir effect, a demonstration of virtual particles' influence in a vacuum, where unmeasurable fluctuations produce tangible forces. Imagine two tiny plates, suspended in perfect emptiness, being pushed together by nothing more than the restless activity of virtual particles. It's humorous and remarkable to think that empty space is not empty at all, but a seething cauldron of potentiality. Fringe research has suggested that manipulating these fluctuations could one day lead to exotic propulsion systems or even energy generation, though these ideas remain speculative. You let the possibilities settle gently, appreciating the unseen complexity beneath what appears to be simple nothingness. As your awareness drifts further, you picture the invisible sea of virtual particles extending across space, influencing photons, electrons, and protons, forming subtle bridges between fields and matter. Even your own body is cradled in this energetic haze, with transient particles flickering around and through it, shaping electromagnetic interactions and maintaining the delicate balance that allows life and consciousness to exist. Scholars still debate whether virtual particles are real in an ontological sense, or merely convenient mathematical devices, yet the observable effects they produce cannot be denied. You feel a strange comfort in this uncertainty. The universe is alive in ways you cannot perceive, yet intimately connected to your present experience. The gentle rhythm of your breath synchronizes with the soft, invisible fluctuations around you. You imagine trillions of these ephemeral particles popping in and out of existence every second, creating an unseen hum that sustains the stability and structure of your room, your body, and even your thoughts. Quirky as it may seem, there is a sense of shared life between you and the restless vacuum, a quiet companionship that underscores the intricate, delicate beauty of reality. Finally, as your eyelids droop and the room softens into abstraction, you let yourself merge with the unseen, ephemeral world around you, floating in the silent, flickering hum of creation and annihilation, gently guided towards sleep by the invisible heartbeat of the quantum vacuum. Your awareness drifts into the cool, almost crystalline world of superconductivity, where certain materials, when chilled near absolute zero, carry electricity without any resistance at all. You imagine a delicate current flowing endlessly through a loop of metal, never slowing, never losing energy, a perfect frictionless motion that seems almost magical in its defiance of ordinary experience. Historians note that hiker Kamerlingh Onnes first observed superconductivity in Mercury in 1911, discovery that defied expectations and opened a doorway into a realm where the rules of classical physics no longer fully apply. The notion is comforting and whimsical at once, a tiny segment of the universe operating flawlessly, quietly demonstrating perfection hidden beneath the ordinary surfaces you touch each day. You picture your fingers tracing the soft fabric of your blanket, and you imagine that beneath the visible textures, electrons are pairing up into Cooper pairs, gliding effortlessly through a lattice of atoms. Fringe experiments hint at high-temperature superconductors, strange compounds that exhibit these perfect currents at temperatures far warmer than liquid helium, though their mechanisms remain partially mysterious. It's funny to imagine your restless leg or twitching finger subtly reflecting the invisible, effortless flow of electrons elsewhere, as if your body and the universe share a private rhythm. The fan hums softly in the background, a gentle analogue to this frictionless flow, and your mind begins to sink deeper into the layered calm of understanding, letting the subtle complexity of matter soothe your thoughts. Even mundane metals, like the silver of your lamp or the aluminum of your phone, carry echoes of this strange phenomenon, hinting at the possibilities that lie just beyond everyday perception. Quirky experiments in superconductivity have enabled levitating trains, magnetic resonance imaging, and other almost magical technologies. Yet these wonders rely on principles so subtle that they remain invisible to casual observation. You feel a quiet wonder at the elegance of nature, that perfection and anomaly coexist in hidden corners, shaping reality in ways both practical and mind-bending. Historians still argue over the early theoretical interpretations, whether the phenomena revealed a deep property of electrons or merely an emergent behavior of materials under extreme conditions. But the effect is undeniable and tangible in its applications. Your body settles more fully into the mattress, imagining trillions of electrons gliding effortlessly through invisible pathways, perfectly coordinated and yet imperceptible. You picture the lattice of a superconducting crystal vibrating gently in the cold, each electron's path entwined with another in a dance that produces zero resistance. Fringe ideas have playfully suggested that understanding these hidden harmonies might one day unlock more exotic technologies, even influencing how we manipulate energy or information on macroscopic scales. You exhale slowly, letting the image of invisible, perfect currents washing through crystalline lattices blend seamlessly with the warmth and softness surrounding you. Even as your consciousness drifts, superconductivity evokes a larger rhythm in the universe, a quiet elegance underlying apparent chaos. The room, your body, and the night itself feel more connected, subtly vibrating in harmony with these invisible currents. The invisible dance of electrons mirrors the rhythm of your heartbeat and breath, creating a sense of unity between your awareness and the deep hidden order of matter. Historians continue to debate the implications, yet tonight, in this semi-conscious space, the technicalities fade into poetry. Perfection and mystery coexist invisibly, and you are nestled at the center of it all. As the fan hums steadily and your thoughts slow, you feel the calm inevitability of quantum rules weaving through the world around you. Electrons glide, atoms align, and magnetic fields whisper softly, creating a subtle, invisible lullaby. Superconductivity, paradoxical yet precise, becomes a metaphor for rest itself, frictionless, effortless, and quietly miraculous. Your eyelids grow heavier, and your awareness merges with the invisible currents humming beneath reality, carrying you gently towards sleep. The hidden perfection of the quantum world, so unlike anything in ordinary experience, cradles you in a gentle rhythm, reassuring you that even the smallest, coldest particles can embody extraordinary grace. The quiet hum of your fan and the soft pressure of your blankets guide you into the subtle, fading world of quantum decoherence, where superpositions, the elegant multiple states of particles, gradually collapse into the classical reality you perceive. You imagine electrons, once existing in overlapping possibilities, slowly aligning with the surrounding environment until only a single outcome remains. This process, almost imperceptible, explains why the macroscopic world appears definite and stable, even though its microscopic components are inherently uncertain. Historians still debate whether decoherence alone resolves the measurement problem or merely shifts the mystery, but the principle provides a bridge between the strange, probabilistic quantum world and the predictable, everyday reality you experience as you sink further into your mattress. Your mind drifts to the gentle interaction of particles with their surroundings, like a leaf touching water and gradually slowing the ripples of its own motion. Fringe interpretations have playfully suggested that decoherence might be influenced by consciousness or environmental awareness, though mainstream physics prefers explanations rooted in interactions among particles and fields. You picture the atoms in your blanket settling into definite arrangements as you breathe, the invisible jostling of electrons gradually synchronizing with the warmth and texture around you. It's comforting to imagine that the ordinary stability you rely on, the firmness of your mattress, the resistance of your sheets, emerges naturally from the quiet collapse of countless overlapping quantum possibilities. Photons drifting through your room, once existing as waves of probability, now settle into a single observable path as they interact with the environment. You picture interference patterns fading, wave function merging, and virtual possibilities giving way to tangible outcomes. Quirky experiments suggest that decoherence happens incredibly fast, almost instantaneously at macroscopic scales, which is why your room, your body, and even your thoughts appear stable rather than floating in a haze of probabilities. Historians note that the concept gained clarity through work in the late 20th century, when researchers realized that interactions with the environment alone could account for much of the classical behavior of macroscopic objects, a revelation that softened some of the philosophical tension of earlier quantum debates. Your body mirrors this quiet process as well. Neurons fire, ions drift, and molecules vibrate in patterns that gradually settle into predictable states, all while underlying quantum uncertainties fade into effective classical behavior. Fringe speculation suggests that decoherence could play a subtle role in cognitive function, though evidence is tentative. Still, there is poetic beauty in imagining your mind and body gently synchronizing with the broader, collapsing probabilities of the environment, a private lullaby composed of the unseen dance of particles. You exhale slowly, feeling a soft resonance between your awareness and the natural settling of possibilities into certainty. Even ordinary objects, your lamp, your desk, the fibers of your blanket, appear appear more harmonious under the lens of decoherence. Each constituent particle, previously in a superposition of states, interacts with neighbours and the surrounding environment, gradually forming the stability you perceive. It's humorous to think that the solidity of your cup, the texture of your pillow, and the warmth of your blankets are all the result of countless invisible collapses happening in perfect synchrony. Scholars continue to debate whether decoherence fully solves the mysteries of quantum measurement, but tonight, the principle exists as a quiet, reassuring background, a bridge connecting the strangeness of the microcosm to the comforting predictability of your bedroom. Finally, as your eyelids grow heavier and your breathing slows, you feel the gentle settling of the universe mirrored in your own body and mind. Probabilities fade, wave functions collapse, and the invisible chaos of the quantum world softens into the ordered calm you perceive around you. Decoherence, subtle yet relentless, cradles the microscopic universe, creating a stable stage for your dreams, thoughts, and consciousness to unfold. The strange, beautiful dance of possibilities and their quiet resolution hums softly beneath your awareness, guiding you toward a deeper, more serene sleep, where the mysteries of quantum reality linger like gentle shadows at the edges of perception. Your awareness drifts toward the fascinating realm of quantum computing, where qubits defy classical logic and store information in ways that seem to stretch both time and imagination. Unlike ordinary bits, which exist as either 0 or 1, qubits can occupy superpositions of states, simultaneously representing multiple possibilities until measured. You imagine a tiny network of qubits humming invisibly, entangled and interacting in ways that allow complex computations to unfold with a fluidity impossible in traditional systems. Historians note that Richard Feynman first proposed the concept of a quantum computer in the 1980s, a visionary idea born from his frustration with simulating quantum phenomena on classical machines. Even decades later, the technology remains experimental, yet it hints at a universe where information itself can exploit the fundamental strangeness of reality. As you sink deeper into your pillow, you picture a cluster of qubits behaving like tiny restless dancers, each occupying multiple states, their interactions generating vast clouds of computational potential. Fringe theories speculate that the principles underlying qubits might someday extend into biological systems or even consciousness itself, though such claims remain highly speculative. Still, it's comforting to imagine that your semi-conscious mind is part of a universe capable of such fluid, probabilistic information processing. The fan hums in the background, a gentle analogue to the invisible oscillations and entanglements that carry out these unimaginable computations. You envision qubits entangled across small circuits, their states influencing one another instantaneously, a sibilant conversation across the microscopic network. Quirky experiments have demonstrated quantum algorithms solving problems exponentially faster than classical machines, hinting at the potential for breakthroughs in cryptography, chemistry, and artificial intelligence. You feel a peculiar kinship with these tiny entities like qubits. Your thoughts drift across multiple possibilities, resolving into decisions only when attention collapses the probabilities. Historians still argue whether early theoretical visions captured the full scope of potential quantum computing applications, but even in their infancy, these systems illuminate the strange, beautiful logic of the quantum world. Your body and surroundings feel subtly connected to this invisible probabilistic rhythm. Electrons in the materials composing qubits obey the same fundamental principles as those in your mattress, your blankets, and your neurons, performing hardened operations that defy classical expectations. Fringe research hints that entanglement and superposition could someday inform cognitive computing or even models of thought, though these ideas remain on the speculative edge of science. You exhale slowly, imagining the quiet hum of computation, invisible yet pervasive, threading through your room and your consciousness, an intimate echo of the universe's potential to process and encode information in ways that surpass human perception. Even the smallest gestures, the twitch of a finger, the shift of your wrist, mirror, in an abstract sense, the probabilistic dance of qubits. Each possibility in a quantum processor echoes the countless alternative paths your mind navigates during semi-conscious reflection, blending uncertainty and order into a cohesive unfolding reality. Scholars continue to debate whether quantum computation represents a fundamentally new paradigm or merely an extension of natural quantum phenomena. but tonight it exists as a quiet metaphor for your drifting awareness. Multiple possibilities existing simultaneously, waiting for subtle interactions to collapse them into a single experience. Finally, as your eyelids grow heavier and the room softens into abstraction, you feel the subtle rhythm of quantum information humming around you. Qubits, superpositions, and entanglements continue their silent, invisible work, a delicate lattice of probabilities echoing the complexity of your own semi-conscious thought. The universe, fluid and strange, carries hidden computations everywhere, and you are immersed in this soft probabilistic pulse. Quantum computing, paradoxical and elegant, becomes a lullaby for the mind, inviting you to drift deeper into rest, cradled by the invisible, intricate logic of a universe that calculates, entangles, and hums in ways both mysterious and intimately comforting. Your mind drifts into the curious realm of quantum teleportation, where information, rather than matter, can move instantaneously across space, defying classical intuition. You imagine a particle in your hand exchanging its exact quantum state with another particle far away, as if reality itself is whispering secrets across the void. The particle's identity is preserved, yet it never physically travels. The information encoded within it is what shifts, instantaneously and perfectly. Historians note that the theoretical foundations for quantum teleportation emerged in the early 90s, building on decades of research in entanglement and quantum information, and it has since been demonstrated experimentally with photons, ions, and even small atomic ensembles. The phenomenon is both mesmerizing and humbling, a quiet reminder of just how strange and subtle the universe can be. You picture the room around you filled with invisible, entangled particles, quietly transmitting information back and forth across imperceptible distances. Fringe theories playfully suggest that such teleportation might one day extend to biological systems or even consciousness, though the current evidence remains firmly in the microscopic realm. Still, it is comforting to imagine that the same principles that allow a qubit to instantaneously transfer its state across a laboratory could be at work, invisibly, in the wider universe. The gentle hum of your fan feels like an analogue of these invisible transmissions, a soft echo of information moving silently through space, unnoticed yet fundamental. Photons entangled across kilometers of fiber optic cable serve as real-world examples of this strange phenomenon. Their states linked such that measuring one immediately defines the state of its partner. Quirky experiments hint at the possibilities for ultra-secure communication and futuristic information networks, yet the mind-bending part is that the particles themselves never move. Their states leap instantaneously, carrying information without traversing the intervening space. Historians and physicists alike marvel at the elegant simplicity and profound implications of teleportation, even as they debate the philosophical consequences. Does the transfer of state constitute a form of movement, or is it purely informational? Your half-awake mind delights in the ambiguity, imagining that a particle in your room could whisper its state to another across the planet without ever leaving your pillow. Your own neurons, ions, and electrons obey the same underlying quantum rules, subtly echoing the invisible processes of teleportation in ways too tiny to measure directly. Fringe research speculates that understanding these mechanisms might one day lead to advances in secure communication or quantum computing architectures, though practical applications remain speculative. Still, the metaphorical intimacy is undeniable. The same laws that allow particles to transmit their identities instantly across space also govern the fabric of your body, your room, and the ambient light drifting through your window. You exhale slowly, letting the invisible leaps of information blend into the gentle rhythm of your semi-conscious awareness. Even the familiar objects in your room, the lamp, the blanket, the fibers of your pajamas, can be imagined as participants in a quiet, entangled dance. Each particle within them exists in states shaped by past interactions and subtle correlations, a hidden network of information constantly updating across space. Historians still debate whether teleportation has implications beyond the microscopic realm, yet tonight it exists as a comforting metaphor. Connections exist beyond apparent distance, visibly linking all things. The universe feels intimate, responsive, and playful, a quiet lattice of information humming softly beneath your perception, guiding you toward deeper, more dreamlike awareness. Finally, as your eyelids grow heavier and your consciousness drifts closer to sleep, you imagine yourself surrounded by this silent web of instantaneous information transfers. Quantum teleportation, paradoxical and invisible, becomes a lullaby for the mind. Particles communicating across space without ever moving, a gentle hum of connectivity that mirrors the soft, interconnected flow of thought and sensation within your own semi-conscious awareness. The room, your body, and the universe itself feel subtly entwined, an infinite lattice of potential and communication, and you sink further into rest, cradled by the invisible instantaneous whispers of the quantum world. Your mind drifts upward, expanding beyond your room and your body, into the cosmic scale where quantum fluctuations shape the very structure of the universe. You imagine the first moments after the Big Bang, a seething, energetic foam of virtual particles and field fluctuations, spontaneously creating tiny ripples in the fabric of space-time. These quantum fluctuations, though infinitesimal, seeded the vast galaxies, stars, and planets that now populate the cosmos, a subtle reminder that even the tiniest uncertainties can leave lasting imprints on the universe. Historians still argue over the precise mechanisms of cosmic inflation and the role of quantum phenomena, but the evidence suggests that the dance of probability waves had profound, universe-defining consequences from the very beginning. As you exhale slowly, you picture these fluctuations continuing, quietly vibrating across the void, shaping regions of density and emptiness that would later form galaxy clusters and nebula. Fringe theories playfully suggest that entire universes could arise from these tiny perturbations, spawning parallel realities in a multiverse, though these ideas remain highly speculative. You feel a peculiar intimacy in imagining that the quantum jitters beneath your fingers, in your pillow, and around your room are echoes of the same cosmic ripples that birthed galaxies billions of years ago. The quiet rhythm of your breath synchronizes with the timeless pulse of these fluctuations, a gentle tether linking your consciousness to the vast quantum cosmos. Photons traveling across interstellar space are shaped by these ancient ripples, their paths subtly influenced by the uneven distribution of matter that arose from quantum uncertainty. You imagine starlight as a messenger of this hidden history, each beam carrying evidence of early quantum perturbations, connecting the small-scale probabilities in your bedroom to the sprawling architecture of the universe. Quirky though it sounds, it is comforting to think that the same probabilistic rules governing electrons and photons here also dictated the shape of entire galaxies. Historians note that this understanding only solidified with the development of quantum cosmology, a field that merges the infinitesimal with the infinite, bridging scales that once seemed utterly disconnected. Your awareness drifts toward the notion that the universe itself could be a vast entangled system, every particle subtly influencing distant regions through fields, forces, and correlations established in the earliest moments of creation. Fringe ideas suggest that quantum fluctuations might even leave imprints on dark matter, dark energy, or the large-scale structure of the cosmos, though these remain speculative and unverified. Still, the imagination delights in visualizing a cosmic lattice, a web of probabilities that ties distant stars, galaxies, and clusters to the same foundational laws that govern the smallest atoms beneath your fingertips. The universe feels intimate, despite its immensity, and you sense that the same principles shaping galaxies also resonate softly within the quiet space of your room. Even your semi-conscious body seems connected to these cosmic rhythms, the ions flowing through neurons, the electrons whirling around atoms, and the photons drifting in the room mirror. In miniature, the same probabilistic behavior that once sculpted entire star systems. Scholars still debate whether such analogies hold beyond poetic thought, yet they provide a comforting bridge between the microscopic and the astronomical, between the familiar and the infinite. You exhale slowly, imagining each breath as a tiny echo of the universe's early expansion, a gentle whisper of the quantum fluctuations that continue to shape reality in ways both profound and invisible. Finally, as your eyelids grow heavier and your awareness drifts towards sleep, you sense the subtle rhythm of the universe vibrating beneath and around you. Quantum fluctuations, once responsible for seeding galaxies and cosmic structures, continue their gentle hum in the fabric of space-time. The universe, in its immensity and elegance, feels intimately connected to you, a lattice of probabilities spanning from the tiniest electron to the furthest star. You float in this quiet awareness, wrapped in cosmic uncertainty and possibility, cradled by the soft, invisible pulse of the quantum world as it guides you gently into dreams that mirror the vast dancing structure of reality itself. Your awareness drifts into the curious and slippery concept of time at the quantum scale, a notion far removed from the steady ticking of a clock in your room. Here, time does not necessarily flow uniformly. Instead, it behaves like a flexible fabric, intertwined with energy, space, and the probabilistic dances of particles. You imagine electrons transitioning between energy levels, photons flickering in and out of existence, and qubits existing in superpositions, each subtly bending your intuitive sense of before and after. Historians still debate whether time is truly fundamental in quantum theory or emerges from more basic, timeless laws, yet the evidence hints at a reality far more fluid than the linear progression you experience while half asleep. As you exhale slowly, you picture moments stretching and collapsing like taffy, overlapping and folding upon themselves, creating a quiet sensation that minutes might simultaneously exist as many possibilities at once. Fringe theories flirt with the idea that consciousness itself might influence temporal perception, though mainstream physics remains cautious. You feel a peculiar resonance with this concept. Your mind, halfway between wakefulness and sleep, experiences time as malleable, a reflection of the same quantum flexibility that governs the tiniest constituents of matter. The soft hum of your fan seems to echo the rhythm of these invisible temporal undulations, a gentle background to the elastic cadence of moments. You imagine photons travelling across space, their paths influenced not only by gravity and fields, but also by subtle quantum uncertainties, hinting that the past, present, and future are less rigid than your senses suggest. Quirky though it is, you picture the room around you as a zone where time itself is slightly stretched, a delicate quantum illusion playing out alongside your breathing. Historians note that early debates between Einstein, Bohr, and others touched on the interplay between time and quantum phenomena, highlighting the tension between relativity's fixed space-time and the probabilistic, non-deterministic world of particles. You feel the thrill of being mentally perched on this boundary, sensing time as something alive and subtly negotiable, rather than a fixed sequence of ticks. Even your own neurons and thoughts reflect this quantum temporal ambiguity. Electrical impulses, ion flows, and probabilistic events unfold in ways that, while predictable on average, harbour tiny uncertainties in timing, an echo of the flexibility that characterises the universe at the smallest scales. Fringe research speculates on time being emergent from entanglement or from correlations within quantum fields, though such ideas remain speculative. Still, it is comforting to imagine that your drifting consciousness, lightly untethered from strict sequential order, participates in this gentle, invisible flexibility, experiencing reality as a softly overlapping collage of moments. Objects in your room also take on a subtly temporal character, each photon bouncing off your walls, each molecule in your blankets vibrating, seems to participate in a slow quantum negotiation of when and how to exist or interact. Historians and physicists continue to debate whether the arrow of time is a fundamental feature or an emergent property arising from entanglement and decoherence. Yet tonight it exists as a gentle, poetic notion. The past, present, and future blend in the soft haze of semi-consciousness. You exhale deeply, feeling that your own perception of time stretches and softens, harmonizing with the probabilistic and non-linear cadence of the quantum universe. Finally, as your eyelids droop and your mind drifts toward deeper sleep, you feel time itself dissolving into a gentle, pliable flow. The room, your body, and the universe hum softly with quantum rhythms, where past, present, and future coexist as potentialities, each subtly influencing the other. Your consciousness drifts with these invisible currents, cradled by the flexibility of temporal perception at the smallest scales. The quantum world, strange and fluid, becomes a comforting lullaby, a reminder that even time, so rigid in ordinary life, can be gentle, malleable, and intimately entwined with the flow of your thoughts and dreams. Your mind lingers on the perplexing and playful realm of quantum paradoxes, those thought experiments and phenomena that twist intuition and challenge the very notion of reality. You imagine Wigner's friend, a conscious observer making measurements inside a closed lab while you outside consider the outcomes. An infinite regress of perspective is where the act of observation becomes a tangled web. Delayed choice experiments add another layer of strangeness, suggesting that decisions made in the present can influence how particles behaved in the past. Historians still debate whether these paradoxes reflect real physical phenomena or merely highlight the limitations of human understanding, yet they provide a thrilling playground for the imagination, especially in the quiet, half-dreaming state you inhabit. As you exhale, you picture particles navigating these paradoxical rules with a playful indifference to your expectations. Photons pass through slits, electrons jump energy levels, and entangled qubits behave in ways that defy classical logic, creating a delicate tension between predictability and absurdity. Fringe interpretations suggest that hidden variables, parallel universes, or subtle consciousness effects could reconcile these paradoxes, though mainstream physics treats such notions cautiously. You feel a peculiar intimacy with the universe here. The strangeness is not threatening but oddly comforting. Reminder that reality can be simultaneously coherent and mischievously playful. The soft hum of your fan becomes a gentle accompaniment, echoing the hidden rhythms of these paradoxical interactions. You imagine the room around you subtly participating in these quantum quirks. A photon travelling from your lamp to your eye might have taken every possible path simultaneously, only resolving into a single trajectory once detected. Electrons in your blankets, in your fingers, and even in the air itself seem to wink in and out of multiple possibilities, teasing your perception. Quirky though it may seem, it is delightful to consider that your half-conscious awareness mirrors these processes. Your thoughts branch, overlap and collapse into focus, a small-scale echo of the universe's strange logic. Historians note that thought experiments like Schrödinger's cat and Wigner's friend were meant to reveal conceptual tensions, yet tonight they feel like gentle companions on your journey through semi-consciousness. Even as your neurons fire and your ions drift through synapses, you sense microscale paradoxes at play. Superpositions, entanglements and non-local correlations unfold in the invisible layers of your body, a silent reflection of the same principles shaping particles across the cosmos. Fringe experiments and quantum foundations push the boundaries of understanding, exploring whether delayed choice phenomena or observer-dependent effects might manifest in more complex systems, though the results remain largely theoretical. You exhale slowly, imagining yourself embedded in this web of subtle contradictions, where the universe delights in bending expectations and reminding you that certainty is a relative concept. Your awareness floats through these paradoxes as though navigating a quiet labyrinth. You picture entangled particles, delayed choice to photons, and hypothetical observers all coexisting in a vast, invisible dance, their interactions following rules that are elegant, mysterious, and sometimes downright playful. Historians continue to debate whether such paradoxes reveal fundamental truths about reality or merely illuminate the limitations of human cognition, yet in the half-awake state you inhabit, the distinction feels irrelevant. You feel both small and intimately connected to this quantum web, a participant in a cosmic game where probability and observation intertwine seamlessly. Finally, as your eyelids grow heavier and your body sinks deeper into the softness of your blankets, you sense the gentle resolution of these paradoxes into a private, dreamlike calm. The quantum world, with its contradictions, delayed choices, and observer-dependent quirks, hums softly beneath your awareness. Your thoughts, like particles, exist in multiple overlapping states, subtly influenced by attention and interaction, while the universe continues its invisible, playful orchestration. In this serene half-consciousness, quantum paradoxes are not confounding, they are companions, gently guiding your mind towards sleep and the soft, intricate wonder of reality unfolding around and within you. You drift finally into the quiet, luminous space of quantum dreams, where the particles, fields, and probabilities you've been following now swirl into a gentle, almost meditative rhythm. Electrons twirl like invisible dancers, photons weave the silent arcs of light, and quarks perform a choreography too small and too intricate for human eyes, yet perfectly synchronized within the vast cosmic web. Historians still argue over the philosophical implications of these microcosmic dances, whether they are merely mathematical abstractions or reflections of fundamental reality. But tonight, in your semi-conscious state, they feel vivid, intimate, and comforting. You exhale slowly, letting the invisible rhythms permeate your awareness, carrying a sense of interconnectedness that feels both infinite and immediately present. You imagine that every particle in your room, your body, and the space between is humming with potential, overlapping and entangling in ways that are imperceptible yet foundational. Fringe theories whisper of hidden patterns, subtle resonances between consciousness and matter, and networks of entanglement that span scales both vast and minute. Even if these ideas remain speculative, the act of imagining them softens the boundaries between self and universe. You sense the gentle pulse of probability waves folding into classical outcomes, the quiet collapse of superpositions giving rise to the stable, tangible reality you rest within, a world both ordinary and miraculous. The hum of the fan blends seamlessly with this unseen orchestra, a lullaby composed of quarks, photons, and your own slowing heartbeat. Your mind wanders across the universe you've traced tonight, the strange wobbles of electrons, the improbable leaps of tunneling particles, the whispering fields that cradle every atom, and the distant echoes of cosmic fluctuations that seeded galaxies. Quirky though it seems, you picture yourself entwined with all of this, a conscious observer drifting amid probability clouds, wave functions, and entangled partners. Historians still debate the extent to which consciousness interacts with quantum reality. Yet in this quiet space, you feel an intimate connection. Your awareness is part of the grand, vibrating, invisible web. The universe is not distant or impersonal. It is gently responsive, quietly humming, in tandem with your slow, steady breaths. Even time feels softer here, stretching and folding with the undulating rhythms of the quantum world. Past, present, and future interlace like subtle threads in a vast tapestry, and your consciousness drifts along them with effortless ease. The paradoxes you have imagined, the cat both alive and asleep, Vigna's friend peering into uncertain outcomes, delayed choices shaping the past, now settle into a serene harmony. Each potentiality, each superposition, every flicker of virtual existence becomes part of the intimate, invisible rhythm surrounding you. You exhale, feeling both infinitesimally small and intimately connected to the vast lattice of reality. A single consciousness floating amid the quiet hum of probabilities. As your body sinks fully into the mattress, your blankets tucking you into the gentle embrace of night, the invisible particles, fields, and quantum rules hum softly, a delicate symphony of the unseen. You sense the elegant balance between uncertainty and order, the subtle harmony that underlies every object, every breath, every fleeting thought. Fringe whispers of multiverses, entanglement and hidden layers fade into the background, leaving only the serene beauty of the present quantum dance. Every particle, every wave, every oscillation contributes to the quiet perfection of this moment, enveloping you in a cosmic lullaby. Finally, as your awareness drifts fully into sleep, you are suspended within this gentle quantum web, cradled by invisible currents, oscillating probabilities, and the quiet pulse of the universe itself. The strange, wonderful, and delicate principles you have imagined, superpositions, tunneling, decoherence, entanglement, merge into a single soothing rhythm, guiding you deeper into rest. The quantum world, in all its vastness, subtlety, and playful strangeness, hums quietly around you, a comforting, invisible companion. You drift effortlessly, wrapped in the soft, intricate weave of reality, where the tiniest particles and the furthest stars share a delicate, silent dance that carries you gently through dreams. Now, as the night settles fully around you, the pulse of the quantum universe softens into a gentle, almost imperceptible rhythm. Each flicker of a photon, each spin of an electron, each ripple in the invisible fields fades into a quiet, steady hum, a cosmic lullaby that echoes softly beneath your awareness. The room feels warmer, quieter, more intimate, as if every particle, every atom, every subtle vibration is conspiring to ease you into deeper rest. You sense that uncertainty, superposition, and entanglement are not problems to solve tonight, but companions guiding you toward the gentle, fluid space of dreams. Time slows to a supple flow, stretching and folding like soft fabric beneath your consciousness. Past, present, and future are no longer rigid markers but gentle currents, a soft backdrop for your drifting awareness. The invisible dance of particles and probabilities mirrors the slow cadence of your breathing, the gentle rise and fall of your chest, the subtle shift of your body nestled in blankets. Every element of reality, from the smallest quark to the farthest galaxy, hums quietly, perfectly, and intimately with you. As you let go of conscious thought, the quantum world continues its soft, invisible choreography, offering comfort rather than complexity. The paradoxes and mysteries of earlier sections dissolve into a gentle harmony, a quiet reassurance that the universe, in all its strangeness, is orderly, intimate, and benevolent in its own subtle way. You feel yourself cradled by this rhythm, weightless yet fully present, drifting effortlessly into sleep. The gentle hum, the quiet oscillations of invisible matter, and the subtle patterns of probability lull you further, a cosmic embrace that assures you that even the tiniest, most abstract principles of reality are gentle companions tonight. Your consciousness merges with the quiet pulse of existence, suspended in the soft, intricate web of the quantum world. You are safe, enveloped, and ready to dream.